Greetings, this is Chemistry with Nav, and in this video we're going to take a look at acids, bases and salts. And starting off with acids, these are substances that dissociate to form H+ ions in aqueous solution. So we're looking at aqueous protons here. And you get two types of acids. The first is strong acids, and these dissociate fully into their ions in water. Examples of strong acids are the ones that we typically come across in the lab, so HCl, hydrochloric acid, HNO3, nitric acid, and H2SO4, sulfuric acid. And the sorts of dissociation we therefore get is HCl turning up as H+ ions and Cl- ions. And this lies so far to the right that in fact it is essentially a full dissociation, and we get our H+ aqueous ions, which is what we are looking for in terms of acidity. A weak acid, on the other hand, will only slightly dissociate. Into its ions. These are quite typically written as HA, that sort of generic description of a weak acid. But a more specific example would be ethanoic acid, which is CH3COOH. Now, because there's only this very slight dissociation, it's an equilibrium. So CH3COOH is in equilibrium with CH3COO- and then the H+. Again, this is all aqueous, and it's that H+ ion that causes the acidity. Okay, so moving on to bases. Bases tend to be substances such as metal oxides and metal hydroxides, but alkalis are soluble bases, and these will dissociate to form OH- ions in aqueous solution. Again, the strong being those that fully dissociate into their ions when in water. For example, we would have sodium hydroxide or barium hydroxide, which is diprosic because it's barium's in group 2. And the dissociation here being a full dissociation again into Na+ and OH- ions. But with a weak base, these only slightly dissociate into their ions. The major example that we have is ammonia, and when this dissociates, we have to dissociate it in the presence of water so that we get the ammonium ion and the hydroxide ion. Okay. Now, most of the stuff that we look at AS about acids and bases refers back to salts and maybe making salts. But what actually is a salt? How would you define them? Well, a salt is the product formed when the H+ ions in an acid are replaced by metal ions or ammonium, so NH4+. If you imagine the formation of sodium chloride, you would do that using hydrochloric acid. The H from HCl is replaced by Na, making sodium chloride. So that's where the definition of salts takes us. But what about making salts? Well, there are three main ways of making salts, and they are mash, bores and corks. It doesn't matter how silly an acronym may be for you to try to remember it, as long as you get the products right. And a metal plus acid gives you a salt plus hydrogen, whereas a base plus acid makes water and salt, and a metal carbonate plus acid gives you water, CO2 and salt as well.